Okay, this is a second series of videos for dietetics looking at issues around foods for dysphagia and foods in general, I guess. So what we're going to look at, this will be a general review of the issues, as I say, with some linkage to the general topic of foods for dysphagia. This is a question, something for you to think about. Food processing, good or bad? What do you think? Over to you to have a consideration about that. Okay, I'll assume you thought about that and maybe pause the video, and we'll go on to discuss some of the issues. Evolutionary perspective is interesting. There is a hypothesis that the most basic of food processing methods, crushing and slicing, contribute to the development of the modern human brain. Chimpanzees spend a large part of their day chewing food. They have large jaw muscles and limited room for the development of larger brains. The hypothesis is that when our hominid ancestors developed tools, food became easy to eat, requiring less time for chewing, smaller jaw muscles, and possibly allowing the development of brains capable of thinking about these issues ultimately. So should have brought that up. So crushing vegetables and slicing meat reduces the amount of chewing without cooking by around 17%, which is obviously quite significant. The next key step was cooking, which made food easy to digest and made most nutrients more bioavailable. It also dramatically improved the taste of food, perhaps leading to socialization with further impacts in developing intelligence. As a link there to a good paper on this. It's a few years old now, but it's got some good material in it. There's also a hypothesis that spoken languages were shaped by changes in the human bite configuration deriving from changes in dietary and behavioural practices since the Neolithic, that is a new Stone Age, which is, broadly speaking, 3,900 to 1,700 years before current era. And again, there's a link there to a paper about this. Obviously, speech is an important part of socialisation and intelligence in general. We can pass on information to other people. And that's what makes us different culturally from every other animal on the planet, essentially. So the benefits of food processing. This EUFIC, European Union Food Information Council website, is a good set of resources on processed food, particularly its advantages, and was well worth having a read about. When you toast bread or fry food, you're producing something called Maillard reactions between amino acids and sugars. Food students will know about these, of course. They're a class of non-enzymatic browning reactions. Another one is caramelization of sugars, where simple sugars react at high temperature to produce complex coloured aggregations. In both cases, many taste and odour compounds are produced, as well as the appearance of the food changing, so greatly increasing its appeal. Crucially, cooking also breaks down things like big molecules like proteins to peptides and amino acids, which significantly improves digestibility and bioavailability. Also for complex starches, raw potato is essentially undigestible, but once it's been cooked, the starches have been broken down into smaller molecules which we can digest. So it's very important cooking for getting nutrients out of food. And here's just one specific example. Lycopene, I'm not sure why it didn't appear straight away. Lycopene is a non-provitamin A carotenoid. Some carotenoids produce vitamin A, this one doesn't, but it is responsible for the red to pink colours in tomatoes, pink grapefruit and other foods. And there is evidence that it provides a range of health benefits. There's also good evidence that processing significantly increases the lycopene concentration of food, and more so than might be expected from concentration effects in pasties and pastes and ketchups. This is also true of many of the nutrients in things like spinach, which are much more released when you cook spinach rather than eating raw spinach. And there are a few other examples of this. Here's another view of the data. Note the high variability in raw compared to the much more higher and much more consistent amounts found in juices and ketchups. Processing, particularly in heating, can cause losses of some nutrients such as vitamins A and C. Linked here is an interactive visualization of cooking time and a range of vegetables, which we'll have a quick look at, I think. Okay, so again, we're looking at various times, we're looking at different foods. So if we took everything off, we look at the effect of 5 minutes, we can say after 5 minutes they've lost this amount of vitamin C. We bring up 15 minutes and we can see that the amount lost is greater, and again greater for 30 minutes because it is damaged by heat. We could look at use sliders to look at the least damage, the most damage. There's various things you can do with these data interactions. Obviously didn't want to do that for some reason, not quite sure why. Yeah, okay, so that works. We could again just look at individual foods. So if we're only interested in pumpkins for some reason, we could highlight the data on pumpkins. Okay, anyway, that was just an interactive visualization showing these effects, which are well understood, and this paper is taken from this paper. Here's another visualization to make the point that food habits have changed and continue to change. So this is taken from UK National Survey data. It's up to 2008. I really need to find some time to update this. I'll get some student to do it for me. And it shows how things have changed over time, going back to just after the Second World War. We see, for example, milk and dairy foods are at a high level up until about the late 1970s, and then they crashed down. We see the rise of skim milk. It's a bit out of date, so it doesn't have things like plant-based milk in here, but it's something to bear in mind. Diets are changing, and of course, different people from different backgrounds have different diets anyway. So there's a lot of things to consider. Okay, professional food product development, which is what you are doing when you are developing foods for dysphagia and considering these issues. It's something you do need to consider. On the right here is the overall process of a food product development used by a well-known local company and typical throughout the industry, and it's complicated. On a smaller scale, you may be doing it on a smaller scale, or you may be getting an outside company to do this for you anyway. It refers to gates here, which are technically called stage gates. If you're interested, look up that term, which are halt proceed decisions at various stages of the process. In terms of foods for dysphagia, the requirements for nutrition and IDSI guidelines will also have to be embedded in the process as well. Interesting guides for caterers are available, such as this one from Premier Foods. Again, just link through the image if you want to have a read of this. Just some general advice. Foods that don't work. These are probably too difficult to actually do unless you massively process them into things like soups. So celery, for example, is probably too fibrous and too chewy. Lettuce leaves are probably too big and floppy, is one suggestion. Grapes, other things which have skins, probably hard to use and have different textures to the body of the food. And again, there's things like which are sticky and springy, which again are probably not a good idea. Surprisingly, jellies, one of the things which you should probably avoid because they change their texture in the mouth, and that again can be an issue. But people have difficulty with swallowing. Foods that do work, many of these, many foods can be processed for use in patients with dysphagia issues. I mentioned Simply Puree in a previous video. It's a company from South Shields who I have good links with, unfortunately interrupted by current issues. Have a look at their website and see some of the products they produce. We'll look at some of these issues in the lab. Key is the food must retain its IDSI rating after it's been cooked by various methods, and preferably after a significant amount of time when it's gone from where it's been heated to the patient. There are a number of issues there which you can have a read about. Again, some background reading just to end up. Beyond the blender, the traditional approach was just to liquidize food, which didn't make it particularly appetizing, obviously. Much more palatable solutions are available now. And there's links there to Dysphagia UK and another cookbook for dining with dysphagia. Okay, that's all, folks. Thanks for listening.